This is GCE C4 May 15, question number 1. Point P lies on the curve with the equation. So this is a curve. This is point P. So this equation is x is equal to 4y minus sine 2y square. Given that P has xy coordinate, P and x over 2. So this coordinate is P and pi over 2, not x over 2, pi over 2. Find the exact value of P. So to find the exact value of P, put x as P, is equal to 4, y is pi over 2 minus sine 2, y is pi over 2 square. So P is equal to, this is 2 pi minus, this 2 and 2 cancel, sine pi is 0. So that is 0 square. So this means P is equal to 4 pi square. So that is the value of P. So these coordinates are 4 pi square and pi over 2. The tangent to the curve P cuts the y-axis at point A. So if there is a tangent, is cutting at A, use the calculus to find the coordinate of A. We know that x coordinate is 0. So we have to find the y coordinate. So first we have to find the equation of tangent. We have the point, we have to find dy over dx. Part B. So x is equal to 4y minus sine 2y square. We can simplify it or we can find it directly, dx over dy. Is equal to 2 4y minus sine 2y multiply the differential of 4y with respect to x is 4 minus sine 2y is cos 2y and multiply by 2. So now this dy over dx at this dx over dy. So dx over dy at y is equal to pi over 2. So this will be equal to 2 4 multiply pi over 2 minus sine 2 y is equal to pi over 2 multiply this is bracket 4 minus cos, this we can write as 2 cos 2 y is pi over 2. So that is equal to, so this is 2 and 2 pi minus sine pi is 0 then 4 minus 2 cos pi. Cos pi is minus 1. So this is equal to 2 multiply 2 pi multiply 6. So that is 24 pi. So the coordinate. So the equation of tangent is if we have to find the coordinate of A, we have to find this and put x is equal to 0. So equation of tangent is y minus y1, that is pi over 2, that is equal to dy over dx. Dx over dy is 24, so this is 24 pi, 1 over 24 pi, x minus x1. So x1 is 4 pi square. At A, x is equal to 0. So y minus pi over 2 is equal to, this multiplies 0, so it is minus 4 pi square over 24 pi, and which is minus pi over 4 times 6, pi over 6. So y will be minus pi over 6 plus pi over 2. So multiplied by 3 multiplied by 3. So that is equal to 6. This is minus pi plus 3 pi. So that is 2 pi over 6. So y is equal to pi over 3. So this is 0 and pi over 3. So these are the coordinates of A. This is the sketch of the curve and the straight line intersecting at A. Show that the x coordinate of A satisfies the equation. So they are intersecting, so solve by using simultaneous equation. So in that case, 17 minus x is equal to 2 is to the power x plus 1 minus 3. So 17 minus x is equal to 2 is to the power x plus 1. 2 is to the power x plus 1 can be written as 2 is to the power x and 2 is to the power 1. So it can be written 2 multiply 2 is to the power x minus 3. So that is 17 plus 3 is 20 minus x over 2 is equal to 2 is to the power x. So this means if we take log on both sides, so ln 20 minus x over 2 is equal to ln 2 is to the power x. Ln 2 is to the power x can be written as x ln 2 is equal to ln 20 minus x. Log a over b is log a minus log b. Now divide all sides by ln 2. this is cancel. So x will be ln 20 minus x over ln 2. This cancel, this is 1. So that is what we are supposed to prove, ln 20 minus x over ln 2 minus 1. Part B is use iteration formula xn plus 1 is equal to ln 20 minus x1 xn over ln 2 minus 1, and it is given that x 0 is equal to 3. So we put n is equal to 0. So x1 is equal to ln 20 minus x0 is 3 over ln 2 minus 1. So that is ln 17 over ln 2 minus 1. That is equal to, so x2 will be ln 20 minus 3.087 over ln 2 minus 1. So if you calculate, you will get it 3.080. And in the same way, x3 will be ln 20 minus 3.080 over ln 2 minus 1. That will be equal to 0.081, 3.081. So this will be 3.081. So that is the value of x1, x2 and x3 up to 3 places of decimals. This is x0, x1, x2, x3. Part C. Use the answer of part B to deduce the coordinate of point A. Give your answer to 1 place of decimal. So from here we can see that 1 places of decimal x is equal to 3.1, and we have y is equal to 17 minus x. X is 3.1. So it means y is equal to 13.9. So the A coordinates will be 3.1 and 13.9. So that is the answer of part C. Part A. It says that gx is equal to x square. If you open the bracket, that will be x square e to the power minus 2x minus x cube e to the power minus 2x. Show that g dash x, that is a differentiate. If we differentiate this, so first function differential of second, that is e to the power minus 2x into minus 2, plus second function e to the power minus 2x and the differential of second, that is 2x, minus first function to differential of second e to the power minus 2x and minus 2, plus second function e to the power minus 2x and differential of first, that is 3x square. So g dash x is equal to, let's simplify this, e to the power minus 2x is common. So this is minus 2x square plus 2x. Same, we can take this common from the second one. This is the first, minus, this is minus 2x cubed plus 3x square. So if we simplify it further, e to the power minus 2x, this is minus 2x square plus 2x plus 2x cubed minus 3x square. That is equal to e to the power minus 2x cubed minus 5x square plus 2x. So that is equal to, so g dash x is equal to, now this is a fx, it's a cubic function, multiply e to the power minus 2x. So this is a fx, so this is the fx, it's a cubic function. B, find the range of g. Now range of g is, so how to calculate this one? That is a, so at this point dy over dx is 0. So let's find dy over dx is equal to 0. So this means this is dy over dx, this is 0, it cannot be 0, so this implies 2x cubed minus 5x square plus 2x is equal to 0. We take x common, so this is 2x square minus 5x plus 2 is equal to 0. X cannot be 0, so this implies 2x square minus 5x plus 2 is equal to 0. So if we simplify, we will get this 2x minus let's simplify it. So this is 4, that is 2x square minus 5x can be written 4x minus x plus 2 is equal to 0. This means 2x common, x minus 2 minus 1 common, x minus 2 is equal to 0. So that is 2x minus 1 and x minus 2. So this implies that x is equal to minus half and x is equal to not minus half, plus half, and x is equal to 2. So this is x is equal to half and this is x is equal to 2. Put these values here. So if x is equal to half, so gx will be half square 1 minus half e to the power minus 2 into half. So that will be 1 over 4, 1 over 2 e to the power minus 1. So that is 1 over 8e. And if it is 2, so gx will be 2 square 1 minus 2 is to the power minus 2 into 2. So that will be 4 is to the power minus 4. So the range is this and this. This is the range. So we can say that gx is less than gx is greater than 1 over 80. No, gx is less than 1 over 80 and gx is greater than 4 e to the power minus 4. So that is the range. Part C. Give the reason why the function does not G inverse. So for inverse function, it is supposed to be one-to-one function. Now if we check this, this is x1, this is y1, this is x2. This is x1, this is x2, and for both there is one value of y. So this is not one-to-one function. So inverse will not exist. Question number 8. Prove that sec 2a plus tan 2a is equal to cos a plus sin a over cos a minus sin a. This is part A. Sec 2a plus tan 2a can be written as 1 over cos 2a plus cos 2a plus sine 2a over cos 2a. So that can be written as cos 2a. So this is cos 2a plus sine 2a. So this is cos 2a, can be written as cos square a minus sine square a. This can be written as 2 sine a cos a over cos 2a is cos square a minus sine square a. So that is, we need cos a plus sine a. This is already cos 2a, so it will be 1. This is 1. So this can be written as 1 can be written as cos square a plus sine square a. So this one will be cos square a plus sine square a plus 2 sine a cos a. This is a square plus b square plus 2ab. That is equal to a plus b square. So this can be written as cos a plus cos a plus sine a square, and this can be written as cos square a square minus b square is equal to a minus b and a plus b. So this part can be written as cos a minus sine a over cos a plus sine a. Cos a plus sine a, cos a plus sine a, this square is cancelled by this, so this is equal to cos a plus sine a over cos a minus sine a. Cos a plus sine a or cos a minus sine a, that is what we are supposed to prove. Now part B, hence solve. So sine 2 theta plus cos 2 theta. Now we have sine 2 theta plus tan 2 theta. So this is already equal to cos theta plus sine theta over cos theta minus sine theta is equal to half. So it means 2 cos theta plus 2 sine theta is equal to cos theta minus sine theta. So it means this is 2 cos theta minus cos theta is cos theta is equal to 2 sine theta minus sine theta, and minus 2 sine theta is 3 sine theta over cos theta. This is minus over cos theta. So it shows that minus 1 over 3 is equal to tan theta. So theta is tan inverse minus 1 over 3. We have to check in the radian. So this is equal to minus 0.3217. Minus 3217, that is roughly this. .3217. So theta will be, our range is 0 to 2 pi. So A, S, D and C. So the answer will be, it should be negative. So first answer is this. That is 2.8198. And second answer, not this, second answer is this. So second answer is this one, 2 pi minus 32.17. This is pi, this answer is pi minus, this is 2 pi minus, so that will be 5.961. 3 places of decimal, so that will be 2.8198 and this, so that is the answer. So this will be 2.820 and 5.961 is the answer.